February 23, 1945. 12 meters beneath the volcanic ash and rock of Mount Suribachi, Sergeant Matsuo Takahashi of the 312th Independent Infantry Battalion pressed his eye to the observation slit carved into the reinforced concrete bunker, watching American Marines advance across the black sand below. His position was perfect, a work of engineering genius, really. The bunker was connected to 47 other defensive positions through a tunnel network that stretched 3 kilometers in every direction, ventilated by shafts that brought fresh air from hidden vents on the mountain's north face. The walls were reinforced concrete, 2 meters thick, proof against anything short of a direct hit from battleship guns. The firing aperture was designed to be nearly invisible from ground level, offering interlocking fields of fire with the Type 96 machine gun positioned 30 meters to his left. Behind him, stacked in the cool darkness, were 4,000 rounds of 7.7 mm ammunition, 72 grenades, emergency rations for 30 days, and 12 jerry cans of water. Takahashi had watched the American preliminary bombardment with something approaching pity for the enemy, 3 days of naval gunfire and aerial bombing that had consumed what must have been hundreds of thousands of shells and bombs, all striking rock and sand, while he and his comrades waited safely in their underground fortress. The Americans would come now, confident that their firepower had softened the defenses, and they would learn what 40 Japanese soldiers in properly constructed fortifications could do to an entire regiment of attackers. Takahashi had studied the American tactics during the island campaigns, had read the intelligence reports about their preference for firepower over maneuver, their reluctance to accept casualties. The bunker's design anticipated all of this. Let them come. Let them expend their ammunition against concrete and stone. Let them learn that no amount of shells could dislodge soldiers who refused to retreat, who had prepared for this moment with 3 years of continuous labor, who understood that this island was Japan's outer defense line and could not be yielded. Takahashi adjusted his rifle, settled into his firing position, and waited for the Americans to enter his kill zone, supremely confident that what he was about to witness would be a tactical masterclass in defensive warfare. What Sergeant Takahashi didn't know, as he sighted down his rifle at the advancing Marines, was that the small tracked vehicles rumbling up from the beachhead weren't standard M4 Sherman tanks, but rather M4A3R3 Zippo flamethrower tanks, each one carrying 290 gallons of napalm fuel mixture and a pressurized system capable of projecting burning gel up to 150 yards with devastating accuracy. More critically, Takahashi had no concept of what American industrial capacity had created in those strange vehicles. Not merely weapons, but a systematic solution to the problem of bunker warfare. A technology so overwhelming and so terrible that it would transform his carefully prepared fortress from an impregnable defensive position into a concrete tomb filled with superheated air and burning death. This wasn't going to be a story about courage overcoming fear, though there would be plenty of both. This wasn't going to be a tale of tactical innovation defeating defensive preparation, though innovation certainly played its role. This was going to be a demonstration of something far more fundamental and far more terrifying than anything Takahashi and his comrades had encountered in their military training. The arrival of industrial warfare's answer to fortification, the systematic application of chemistry and mechanics to the problem of dislodging soldiers from positions that were immune to conventional weapons. What was about to unfold on the slopes of Mount Suribachi wasn't combat in any traditional sense. It was the collision between 19th-century defensive doctrine and 20th-century industrial horror, between Japanese assumptions about what warfare entailed and American capacity to invent new forms of destruction when old forms proved insufficient. The flames were coming, and no amount of concrete could stop them. The Battle of Iwo Jima had begun on February 19, 1945, with the largest amphibious assault in the Pacific War to date. The Japanese defenders, commanded by Lieutenant General Tadamichi Kuribayashi, had spent 3 years transforming the 8-square-mile volcanic island into the most heavily fortified position in military history. They had constructed 11 miles of tunnels, 1,500 rooms carved into solid rock, 5,000 cave and bunker positions, all interconnected, all mutually supporting, all designed to survive bombardment and protect defenders from the crushing firepower that the Americans would inevitably bring. Kuribayashi had studied American tactics extensively and understood that the U.S. military's doctrine emphasized overwhelming material superiority, naval gunfire, aerial bombing, massed artillery, followed by infantry assault, so he designed his defenses to neutralize that doctrine. The bunkers were positioned in depth, not on the beaches where they could be destroyed by naval guns, but inland where they commanded the approaches. The firing positions were small, camouflaged, interconnected by tunnels, so that if one position fell, soldiers could retreat through underground passages to another position and continue fighting. Every cave had multiple entrances. Every bunker had multiple firing apertures. Every defensive position was pre-registered for indirect fire from Japanese mortars and artillery positioned deeper in the island's interior. The 21,000 Japanese defenders had enough food, water, and ammunition to fight for months, and they had explicit orders not to conduct wasteful banzai charges but rather to kill as many Americans as possible before dying in place. It was, from a defensive engineering standpoint, brilliant. Kuribayashi had created a fortified zone that could not be bypassed, could not be starved out, and he believed could not be destroyed by conventional firepower. The Americans would have to dig them out position by position, bunker by bunker, and that would cost thousands of casualties. The American V Amphibious Corps, landing on February 19th with 70,000 Marines from the 3rd, 4th, and 5th Marine Divisions, had indeed encountered exactly what Kuribayashi anticipated. Japanese defenders who were invisible until they opened fire, who were immune to preliminary bombardment, who could not be suppressed by conventional weapons. The Marines, advancing across Iwo Jima's black volcanic sand, were taking casualties from bunkers they couldn't see, from positions they couldn't identify, from interlocking fields of fire that turned the island into a shooting gallery, where the targets were American soldiers and the shooters were invisible Japanese defenders in concrete fortifications. Standard Marine tactics, fire and maneuver, squad rushes, suppressing fire were failing because you can't suppress what you can't see, and you can't maneuver when every piece of ground is covered by multiple firing positions. By February 23rd, when Takahashi was watching from his bunker, the Marines had suffered over 6,000 casualties in just 4 days of fighting and had advanced only 700 meters inland from the beaches. The initial projections had estimated the island would fall in 5 days. It was becoming clear that Iwo Jima might take weeks, might cost tens of thousands of casualties, unless the Americans found a solution to the bunker problem. They had found a solution. They had manufactured it in American factories, shipped it across the Pacific, and were about to introduce it to the Japanese defenders. The solution was fire. The M4A3R3 flamethrower tank approaching Takahashi's position was a standard M4A3 Sherman tank that had been systematically modified for one specific purpose: burning defenders out of fortified positions. The main 75mm gun had been removed and replaced with an E4-5 flamethrower mechanism, a device that used compressed air to propel burning napalm through a gun-shaped nozzle. The hull bow machine gun had been replaced with a secondary flamethrower for close-range work. Inside the tank, where ammunition racks would normally be positioned, were 2 fuel tanks containing 290 gallons of napalm, a jellied gasoline mixture developed by Harvard chemists in 1942 that burned at 2,200 degrees Fahrenheit, stuck to any surface it contacted, and could not be extinguished with water. The napalm was mixed with white phosphorus for ignition reliability, creating a fuel mixture that would burn underwater, that would consume oxygen from enclosed spaces, that would penetrate any opening and follow air currents through tunnels and bunkers. The pressurized projection system could throw this burning mixture up to 150 yards in a stream that was 6 feet wide at the point of impact, and the tank carried enough fuel for approximately 80 seconds of continuous firing before needing refueling. The M4A3R3 weighed 33 tons, had armor sufficient to protect against Japanese anti-tank weapons, could move at 25 miles per hour across flat ground, and was specifically designed to drive directly up to bunker apertures and pour fire through the openings. The Marines had nicknamed them Zippos, after the popular American cigarette lighter, and they were about to demonstrate why fortified positions that could resist 16-inch naval shells would prove completely vulnerable to a weapon that didn't rely on explosive force at all. But the true horror of the M4A3R3 wasn't its technical specifications, it was what American industrial capacity had done with the concept. The United States had produced approximately 800 flamethrower tanks by February 1945, deployed across the Pacific Theater, wherever Japanese fortifications were encountered. These weren't experimental weapons or limited production prototypes. They were standard equipment, manufactured on production lines in Detroit alongside regular Sherman tanks, each one identical to the next, each one filled with napalm produced in chemical plants that had been civilian facilities 18 months earlier. The Chemical Warfare Service had established production facilities capable of producing 10 million pounds of napalm per month, enough to fill 34,000 flamethrower tank loads. The napalm itself was shipped in powder form, aluminum naphthenate and aluminum palmitate, mixed on site with regular gasoline, meaning that logistics for flamethrower tanks were no more complicated than logistics for conventional tanks. An M4A3R3 could be refueled from standard gasoline supplies available at any Marine forward depot, with the napalm gel powder added from 50-pound sacks that could be transported in regular supply trucks. The Americans had industrialized fire, had made it as routine and available as bullets or shells, had created a logistics system that could deliver burning death to any location on the Pacific battlefield with the same efficiency that it delivered food or ammunition. And critically, the Americans had trained hundreds of tank crews specifically for flamethrower operations, teaching them not just how to operate the equipment, but how to coordinate with infantry, how to identify bunker positions, how to approach fortifications from angles that minimized exposure to anti-tank fire, how to pour flames into cave mouths and bunker apertures with systematic precision. The M4A3R3S, approaching Takahashi's position, weren't random vehicles with new weapons. They were the mobile component of a comprehensive doctrine for destroying fortifications, a doctrine that had been tested on Saipan, refined on Peleliu, and perfected specifically for Iwo Jima. The first indication Takahashi had that something was wrong came when the lead Sherman tank, rather than positioning for hull-down firing as he expected, drove directly toward his bunker at full speed. This was suicide. Takahashi thought a tank, approaching a fortified position, was vulnerable to anti-tank weapons, mines, close assault by infantry with explosives. He sighted his rifle on the Marines following the tank, preparing to fire, when the tank's turret traversed smoothly to point directly at his firing slit, and instead of the expected muzzle flash of a 75mm gun, a stream of orange-yellow flame erupted from the barrel and arced across the 40 meters separating tank from bunker, with the grace of water from a fire hose. The flame struck the bunker's concrete face and splashed across the surface like liquid. And then, impossible, unimaginable, the burning gel began pouring through the firing slit, through the ventilation shaft. Takahashi had considered a brilliant defensive feature, through every crack and gap in the concrete that the engineers had assured him were insignificant. The interior of the bunker transformed in 3 seconds from a cool, dark fortress into a furnace filled with burning air and flaming liquid that clung to walls, floor, ceiling, and men. Takahashi had 1 second to comprehend what was happening. The Americans had a weapon that ignored fortifications, that turned defensive positions into ovens, and then the flames reached the ammunition stockpile, and the bunker exploded from within. The reinforced concrete walls that were supposed to protect against naval bombardment now containing and magnifying the blast, killing everyone inside instantly. The Marine Corps had deployed 8 M4A3R3 flamethrower tanks to Iwo Jima, assigned to support the assault on Mount Suribachi and the heavily fortified northern sectors of the island. These 8 tanks, operating over a period of 3 weeks, would be directly responsible for destroying or neutralizing approximately 750 Japanese defensive positions, bunkers, pillboxes, caves, and fortified buildings that had proven resistant to conventional weapons. Each flamethrower tank could engage and destroy an average of 3 fortified positions per day before requiring refueling and maintenance, and each engagement followed the same brutal pattern. Approach the position, identify the primary opening, pour flames through the opening for 10 to 15 seconds, Move to the next position. The Marines learned quickly that the flamethrower tanks were more effective than any other weapon system for bunker destruction. A 75mm tank gun might fire 50 rounds at a bunker and achieve nothing if the bunker was properly constructed with reinforced concrete and overhead cover. A flamethrower tank needed one 15-second burst, one shot of flames through the opening, and the position was neutralized, everyone inside dead from fire, from oxygen depletion, or from the pressure wave when stored ammunition cooked off. The mathematics were elegant and terrible. 290 gallons of napalm, 80 seconds of firing time, divided into 5 to 15-second bursts, meant one flamethrower tank could destroy 6 to 16 fortified positions before needing refueling. 8 tanks, operating continuously for 3 weeks, could theoretically destroy 1,000+ positions. The actual number was lower, approximately 750, because not all positions could be reached by tanks, because the tanks were vulnerable to anti-tank fire when stationary and firing, because the terrain on Iwo Jima included areas where tanks couldn't maneuver. But 750 fortified positions destroyed by 8 tanks was a casualty rate that no infantry force could match with conventional weapons. The flamethrower tanks were killing machines of unprecedented efficiency. The Japanese defenders' response to the flamethrower tanks revealed the complete mismatch between their defensive doctrine and American offensive capability. Japanese engineers had designed the bunkers and tunnels to resist explosive force naval shells, aerial bombs, artillery fire, all of which worked by fragmentation and blast overpressure. The fortifications were brilliantly effective against those threats, because concrete and rock absorbed explosive force, because depth and overhead cover protected against fragmentation, because small apertures limited the entry of blast waves. But fire doesn't care about blast absorption. Fire follows air currents, penetrates any opening, consumes oxygen, and generates heat that kills through thermal injury and asphyxiation. The very features that made the Japanese fortifications effective against conventional weapons, the interconnected tunnels for protected movement, the ventilation shafts for breathable air, the multiple firing apertures for interlocking fields of fire, became vulnerabilities when flamethrower tanks appeared. A tunnel system designed for lateral movement became a chimney that drew flames deep into the defensive position. Ventilation shafts designed to bring fresh air instead brought superheated gases and toxic smoke. Multiple firing apertures meant multiple entry points for flames. The Japanese had built fortifications that were perfect for fighting the previous war, for resisting the kinds of weapons that had been used at Tarawa and Saipan, and the Americans had invented a new weapon specifically designed to defeat those fortifications. The psychological impact of the flamethrower tanks was as significant as their physical destruction. Japanese soldiers who survived flamethrower attacks, and there were some soldiers positioned deep enough in tunnel systems to escape the flames, soldiers who managed to evacuate through secondary exits, reported a consistent pattern of trauma. They described the flames not as a weapon but as a force of nature, an elemental horror that couldn't be fought with conventional tactics. You couldn't shoot flames with a rifle. You couldn't hide from flames in a bunker. You couldn't retreat from flames through tunnels because the flames followed you. The sound of the M4A3R3 approaching the distinctive diesel engine roar, the clank of treads on volcanic rock became a signal for panic. Japanese soldiers who had held positions courageously against rifle fire, machine guns, grenades, and artillery would abandon positions immediately upon hearing the sound of flamethrower tanks. The weapon produced a learned helplessness similar to what gas attacks had produced in World War I. The sense that your defensive preparations, your courage, your tactical skill were all irrelevant against an enemy who could kill you regardless of cover or concealment. After the first week of fighting on Iwo Jima, Japanese commanders began circulating warnings about the flamethrower tanks, describing them as fire dragons, and advising soldiers to evacuate positions immediately if tanks approached. But evacuation meant abandoning prepared positions, meant exposing yourself to rifle fire from Marines, meant surrendering the defensive advantage that the fortifications provided. The flamethrower tanks had created a tactical dilemma with no solution. Stay in the bunker and die from flames, or leave the bunker and die from bullets. The technical evolution of the flamethrower as a weapon system illustrated the American approach to military problem-solving. Identify a tactical challenge, engineer a solution, Mass-produce the solution. Deploy it systematically. Portable infantry flamethrowers had been used by Marines since Guadalcanal, but they had significant limitations. The M2 man-portable flamethrower weighed 70 pounds fully loaded, could fire for only 7 seconds before exhausting its fuel supply, had a maximum range of 40 yards, and required the operator to expose himself to enemy fire while approaching close enough to use the weapon. Flamethrower operators on Pacific Islands had casualty rates approaching 60% because they had to get within grenade range of enemy positions to be effective, and they were carrying 70 pounds of flammable fuel on their backs. The M4A3R3 tank eliminated all these vulnerabilities. The tank's armor protected the crew. The vehicle's mobility allowed rapid approach to targets. The pressurized system extended range to 150 yards, and the 290-gallon fuel capacity provided 80 seconds of continuous operation. The tank-mounted flamethrower was approximately 10 times more effective than the man-portable version in terms of positions destroyed per hour of operation, and the crew casualty rate was approximately 90% lower. The Americans had taken a weapon with limited tactical utility and high operator risk and transformed it into a weapon with decisive tactical impact and acceptable risk. This transformation required industrial capacity, the ability to build 800 specialized tanks, and logistical sophistication, the ability to supply those tanks with fuel across thousands of miles of ocean. The Japanese had no equivalent weapon because they lacked both the industrial capacity to build specialized armored vehicles in quantity and the logistical system to supply them in forward combat zones. On February 24th, one day after Takahashi's bunker was destroyed, Lieutenant Hiroshi Yamamoto, commanding a company of 150 men, defending the northern approaches to Airfield Noba 2, watched through binoculars as 6 American tanks approached his defensive sector. His positions were even more elaborate than Takahashi's, a network of fortified buildings, underground bunkers, and cave positions that commanded the airfield from 3 directions. Yamamoto had 18 machine guns, 4 anti-tank guns, 200 rifles, and enough ammunition to fight for weeks. His men were veterans, survivors of campaigns in China and Manchuria, soldiers who understood defensive warfare and had prepared for this moment with meticulous care. The Americans had tried to assault his positions twice already with conventional infantry attacks, and both times his men had repulsed them with heavy casualties. Now the Americans were trying tanks, which Yamamoto actually welcomed. Tanks were vulnerable to his anti-tank guns, and once the lead tank was destroyed, the others would be trapped on the narrow approach road. He gave orders to his anti-tank gun crews: wait until the lead tank was within 200 meters, hit it with 3 guns simultaneously, destroy it, and block the road. The plan was sound. The mathematics favored the defenders. Yamamoto settled into his command post to watch the attack fail, confident that his preparations and his men's discipline would carry the day. Except the mathematics didn't favor the defenders at all, because Yamamoto's calculations assumed the tanks would fight with guns, would need to stop and aim and fire, would be vulnerable during that stationary firing period. The M4A3R3S didn't stop. They accelerated, spreading out in a line abreast formation, each tank heading for a different section of the defensive perimeter, their turrets traversing as they moved. Yamamoto's anti-tank guns opened fire at 180 meters. Excellent range, proper lead, 3 guns, firing simultaneously at the lead tank. 2 rounds missed. 1 round struck the tank's glacis plate and ricocheted harmlessly away. The tank kept coming. At 100 meters, the tank's flamethrower erupted, and a stream of burning napalm arced across the distance and splashed directly into the firing slit of the bunker housing Yamamoto's first anti-tank gun. The crew had 3 seconds of screaming horror before the flames consumed them and their bunker became a crematorium. The second and third tanks engaged Yamamoto's machine gun positions, pouring flames through apertures into trenches across fortified buildings. The fourth tank drove directly to a cave mouth that housed 30 of Yamamoto's men and discharged 15 seconds of continuous flame into the opening. The cave's depth, which the engineers had insisted would protect against any weapon, became a death trap as flames followed the tunnel system deep into the mountain, consuming oxygen, generating carbon monoxide, creating superheated air that killed through thermal injury to lungs and airways. The entire defensive position that Yamamoto had prepared for 3 years, that had cost the lives of workers who had built it, that represented the culmination of Japanese defensive engineering doctrine, was neutralized in 11 minutes. 11 minutes from the time the tanks crossed the 200-meter line to the time the last flames were discharged. Yamamoto himself survived because his command post was positioned 400 meters from the forward positions, deep enough that the flames didn't reach him. He emerged from the tunnel network to find his entire company dead or dying, his carefully prepared defenses smoking ruins, and the American Marines advancing behind the tanks, mopping up survivors with rifle fire and grenades. The industrial disparity that made the flamethrower tanks possible extended beyond the vehicles themselves to every aspect of their operation. The napalm fuel mixture was manufactured in the United States by E.I. DuPont de Nemours and Company, Dow Chemical Company, and Standard Oil of New Jersey corporations that had converted peacetime facilities for wartime production. The total American production capacity for napalm in February 1945 was approximately £10 million per month, produced in facilities across 7 states. This production volume meant that supplying 8 flamethrower tanks on Iwo Jima required approximately 0.01% of monthly napalm production, essentially a rounding error in the overall production statistics. The Chemical Warfare Service maintains stockpiles of napalm powder at every major Pacific base, with sufficient reserves to supply flamethrower operations across simultaneous campaigns on multiple islands. When the M4A3R3S on Iwo Jima needed refueling, supply trucks delivered 55-gallon drums of gasoline and 50-pound sacks of napalm powder from beach depots that were being continuously resupplied by Liberty ships arriving every few days. The entire logistics chain, from factory to frontline, operated with such efficiency that flamethrower tank crews never faced fuel shortages, never had to ration their usage, never had to worry about whether they could afford to engage a target. If a bunker existed, they burned it. If a cave existed, they burned it. If a fortified building existed, they burned it. The abundance mentality that defined American military operations in 1945 applied to fire, just as it applied to ammunition, fuel, food, and every other supply category. The Japanese, by contrast, had experimented with flamethrower weapons, but had never developed them into tactically significant systems because they lacked the industrial capacity to produce flamethrower fuel in quantity and the logistical system to deliver it to forward combat zones. The Imperial Japanese Army had approximately 200 man-portable flamethrowers in its entire inventory in February 1945, distributed across all theaters of operation, with limited fuel supplies and no production capacity to replace losses. Japanese military doctrine emphasized weapons that could be manufactured with limited industrial resources and supplied through constrained logistics: rifles, machine guns, mortars, hand grenades. Specialized weapons systems that required dedicated fuel supplies, like flamethrowers, were viewed as tactical luxuries that couldn't be supported by Japan's strained industrial base. The result was predictable. Japanese soldiers faced American flamethrower tanks with weapons designed for a different kind of war, with no tactical doctrine for countering flame weapons, with no counter-technology of their own. They could shoot at the tanks with rifles, which did nothing. They could fire anti-tank guns, which sometimes penetrated armor but often failed because the M4A3R3's frontal armor was 90 millimeters thick, sufficient to defeat most Japanese anti-tank weapons at combat ranges. They could attempt close assault with magnetic mines or satchel charges, which sometimes succeeded but usually resulted in the attacker being burned alive before reaching the tank. The flamethrower tanks operated with near impunity because the Japanese had no effective counter to them. By February 28, 9 days into the battle, the Marines had secured Mount Suribachi and were advancing into the northern sector of Iwo Jima, where the heaviest Japanese fortifications were concentrated. The terrain here was nightmarish for attackers. Volcanic rock formations, gullies, ridges, every piece of ground covered by interlocking fields of fire from bunkers carved into stone. The Marines were taking casualties at rates approaching 20% per day in some units, and progress was measured in meters rather than kilometers. Intelligence estimates suggested the northern sector contained approximately 1,200 fortified positions, and at current rates of advance, securing the sector would take weeks and cost thousands more casualties. The flamethrower tanks became the primary assault weapon. Marine infantry doctrine was modified to accommodate them. Rather than leading attacks, infantry would follow the flamethrower tanks at distances of 50 to 75 meters, allowing the tanks to neutralize bunkers before infantry approached. The tanks would advance in pairs, one tank firing while the second tank provided overwatch, leapfrogging forward. When a fortified position was identified, both tanks would engage simultaneously from different angles, ensuring that if one tank's flames missed the primary opening, the second tank's flames would enter through a secondary opening or ventilation shaft. The technique was systematic, methodical, and devastatingly effective. A typical assault sequence would see the tanks advance 100 meters, engage and destroy 3 to 5 fortified positions, allow infantry to secure the destroyed positions, then advance another 100 meters, and repeat. Progress in the northern sector accelerated dramatically once this technique was perfected. Areas that would have required days to secure with conventional weapons were cleared in hours by the flamethrower tanks. The human cost of the flamethrower tank operations was largely invisible to American forces because the weapon killed by fire and asphyxiation, leaving corpses that were burned beyond recognition or not recovered at all. When Marines secured positions after flamethrower attacks, they typically found bunkers filled with charred remains, cave mouths that emitted smoke for hours after engagement, defensive positions where the heat had been so intense that metal weapons had melted and concrete had cracked. The smell of burned flesh became so pervasive in the northern sector of Iwo Jima that Marines wore handkerchiefs over their faces, and many soldiers developed respiratory problems from inhaling smoke and toxic fumes. Japanese soldiers who had been burned but not killed immediately often died from their injuries over periods of hours or days, suffering from thermal burns, smoke inhalation, and shock. The flamethrower tanks didn't just kill enemy soldiers. They created conditions of suffering that exceeded even the considerable violence of conventional warfare. This wasn't lost on the Marines who witnessed the weapon's effects. Many soldiers expressed discomfort with the flamethrower tanks, recognizing that while the weapon was effective, it produced deaths that seemed particularly horrific even by the standards of war. But the calculus was simple. Flamethrower tanks saved American lives by destroying Japanese positions without requiring Marines to assault those positions with rifles and grenades. Each bunker destroyed by flamethrowers was a bunker that didn't have to be taken by infantry assault, and infantry assaults against fortified positions typically cost casualties measured in double digits. The flamethrower tanks were terrible weapons, but they were less terrible than the alternative. On March 9th, 2 weeks into the battle, Captain Noboru Sasaki of the 145th Infantry Regiment wrote in his diary a document later recovered by American intelligence, what would become one of the most revealing accounts of the Japanese perspective on flamethrower tanks. Sasaki had commanded a defensive sector north of Airfield No. 2 for 11 days, had watched his company of 120 men reduced to 40 survivors, had seen position after position destroyed by the American flame tanks. His entry read, "The Americans have brought hell to our island. We prepared for 3 years, built fortifications that could withstand any bombardment, positioned our men with perfect fields of fire, and still we die. Not from shells or bullets, which are honorable deaths for soldiers, but from fire that penetrates every defense, that follows us into our tunnels, that turns our bunkers into furnaces. I watched today as a single enemy tank destroyed 6 of our positions in 15 minutes. 6 positions that cost us months to build, that housed 40 men with machine guns and anti-tank weapons, eliminated by 1 tank with a flame weapon. How do we fight this? We cannot retreat because there is no place to retreat to. We cannot hide because the flames find us anywhere. We cannot counterattack because the tanks are armored against our weapons. The Americans have solved war. They do not need to fight us with soldiers. They simply burn us like insects. I understand now why we are losing this war. It is not because we lack courage, or training, or determination. It is because the Americans have turned war into an industrial process, and we cannot match their production. They build machines that make courage irrelevant, that make fortifications useless, that make our preparations meaningless. The realization is crushing. We are not fighting an army, we are fighting American factories, and factories always win in the end. I will die on this island, burned alive or shot, or buried in rubble when my bunker collapses. And my death will accomplish nothing, because tomorrow the Americans will send another tank with another 300 gallons of fire, and my replacement will die as uselessly as I did. The entry ended there. Captain Sasaki was killed on March 11th when his command bunker was engaged by two M4A3R3S operating in concert. His diary was recovered by Marines 3 days later and forwarded to G2 Intelligence, where it was translated and filed among thousands of similar documents, notable primarily for its explicit acknowledgement of what many Japanese officers had realized but few had articulated so clearly. They were losing not because they were worse soldiers, but because they were poorer industrialists. The Battle of Iwo Jima continued until March 26, 1945, a total of 36 days of combat that cost the Marines 26,000 casualties, including 6,800 killed. The Japanese defenders suffered approximately 18,000 killed, with only 216 prisoners taken, meaning that 99% of the Japanese garrison fought to the death rather than surrender. These casualty figures reflected the brutal nature of the fighting, but they also reflected the effectiveness of American weapon systems, particularly the flamethrower tanks. Post-battle analysis conducted by Marine Corps Intelligence estimated that the 8 M4A3R3 flamethrower tanks deployed on Iwo Jima had directly destroyed or neutralized approximately 750 fortified positions and had been responsible for killing an estimated 3,500 to 4,000 Japanese soldiers, approximately 20% of the entire Japanese garrison. This meant that 8 tanks with crews totaling 32 men had inflicted casualties equivalent to what would normally require an entire Marine regiment of 3,000 men to achieve through conventional assault. The force multiplication factor of the flamethrower tanks was approximately 100 to 1. One man operating a flamethrower tank was as effective as 100 Marines conducting infantry assaults. The mathematics of this disparity explained why the Marines had been so enthusiastic about the flamethrower tanks, despite their horrific effects. They saved American lives by reducing the need for close assault, and in the brutal calculus of military operations, saving friendly casualties justifies almost any method. The technological evolution didn't stop with the M4A3R3. By late 1945, American engineers were developing improved flamethrower systems with longer range, up to 200 yards, larger fuel capacity, 400-plus gallons, and better flame projection characteristics. They were experimenting with napalm variants that burned hotter, stuck more tenaciously to surfaces, and generated more toxic smoke. They were designing specialized vehicles with multiple flamethrowers that could engage targets simultaneously from different directions. They were developing doctrine for flamethrower aircraft that could drop napalm bombs on fortified positions from altitude. The entire trajectory of American weapons development in 1945 pointed toward greater and greater capacity to project fire as a weapon system, because fire had proven so effective against Japanese defensive positions. If the war had continued, if the atomic bombs hadn't ended the conflict in August 1945, the American assault on the Japanese home islands would have featured hundreds of flamethrower tanks, thousands of man-portable flamethrowers, and extensive use of napalm bombing against Japanese cities and military installations. The plans for Operation Downfall, the proposed invasion of Japan, called for the production of 2,000 additional M4A3R3 tanks and 100,000 tons of napalm, quantities that reflected American industrial capacity to mass-produce fire as casually as they mass-produced bullets or bombs. The Japanese defensive preparations for the home islands, extensive fortifications, cave systems, prepared positions, would have been systematically destroyed by flame weapons that made fortifications irrelevant. The disparity between American and Japanese capabilities extended beyond flamethrowers to every aspect of military operations on Iwo Jima. The Marines landed with 70,000 men, 450 ships, 1,500 aircraft, unlimited ammunition, continuous supply, and the logistical capacity to sustain combat operations indefinitely. The Japanese defenders had 21,000 men, no ships, no aircraft, limited ammunition that could not be resupplied, and the certain knowledge that they would receive no reinforcements, no support, no relief. The Americans could afford to expend hundreds of thousands of shells in preliminary bombardment because their supply chain stretched back to factories that produced millions of shells per month. The Japanese rationed every bullet because they had no supply chain at all. The ammunition they brought to Iwo Jima was all they would ever have. The Americans could withdraw units that suffered heavy casualties, rest them, replace losses, and send them back into combat. The Japanese had no replacement system. Every casualty permanently reduced their combat strength. The Americans could afford tactical mistakes because they had the resources to recover from errors. The Japanese could not afford any mistakes because they had no margin for error. The entire battle was predetermined by these disparities. The Japanese fought with extraordinary courage and skill, but courage and skill cannot overcome industrial production differences measured in orders of magnitude. The Americans won Iwo Jima because they had more of everything. More men, more weapons, more ammunition, more fuel, more food, more medical supplies, more engineering equipment, more naval support, more air support, and more capacity to sustain losses and continue fighting. The flamethrower tanks were simply the most visible manifestation of this fundamental disparity, a weapon that existed because American industry could afford to build specialized vehicles for specialized purposes, supported by specialized fuel supplies, delivered through a specialized logistics chain. The Japanese had no equivalent because they couldn't afford specialization. They needed weapons that could be produced cheaply, supplied easily, and used by soldiers with minimal training. The two armies were fighting on different technological planes, and the outcome was never in doubt. The legacy of the flamethrower tanks at Iwo Jima extended far beyond the battle itself. The weapon system proved so effective that it became standard equipment for Marine divisions throughout the remainder of the Pacific War. Every Marine division that participated in the Okinawa campaign was equipped with flamethrower tanks, and those tanks were employed using the doctrine refined at Iwo Jima: advance with infantry support, engage fortified positions with sustained flame, move to next target. The Japanese defenders on Okinawa, having received reports about Iwo Jima, attempted to develop counters to flamethrower tanks, positioning anti-tank guns to engage at longer ranges, creating defensive positions with multiple sealed compartments to prevent flame penetration, training soldiers in close assault tactics against tanks. None of these measures proved particularly effective because the fundamental problem remained unsolved. You cannot defeat a weapon system backed by unlimited industrial production and logistical support with defensive tactics alone. The flamethrower tanks on Okinawa destroyed approximately 1,200 fortified positions over an 82-day campaign, contributing directly to American victory while minimizing Marine casualties from bunker assaults. The weapon system had become routine, just another tool in the American military's extensive toolkit, deployed as casually as artillery or air support. The psychological impact on Japanese defenders extended beyond individual battles to strategic calculations at the highest levels of Japanese military command. Intelligence reports from Iwo Jima and Okinawa describing American flamethrower tanks contributed to the Japanese government's decision to seek terms for ending the war, because the reports made clear that Japan's defensive strategy for the home islands was fundamentally compromised. The plan had been to fortify Japan with millions of soldiers in prepared positions, making any American invasion so costly that the United States would negotiate rather than fight. But if the Americans could neutralize fortifications with flamethrower tanks, if they could burn defenders out of positions regardless of how well those positions were constructed, then the entire defensive strategy collapsed. The home islands would still be defended by millions of soldiers, but those soldiers would be vulnerable to a weapon system that made courage and preparation irrelevant. The strategic calculus shifted. Instead of forcing a costly American invasion that might lead to negotiated settlement, Japan faced the prospect of systematic destruction by fire, with fortifications providing no protection and casualties mounting. without any corresponding American losses. This realization that American industrial capacity had produced a weapon that nullified Japan's only remaining strategic advantage contributed to the decision to accept surrender after the atomic bombings. The war ended not just because of nuclear weapons, but because Japanese leadership understood that continuing to fight meant continuing to lose, and that American industrial capacity would produce whatever weapons were necessary to achieve victory regardless of Japanese defensive measures. In the final analysis, the story of flamethrower tanks at Iwo Jima is a story about the nature of modern war, about what happens when industrial production becomes the determining factor in military outcomes. The Japanese soldiers on Iwo Jima were brave, skilled, well-trained, and fighting from carefully prepared positions. They did everything right according to the military doctrine of defensive warfare. They built fortifications that could resist conventional weapons. They positioned their forces to create interlocking fields of fire. They prepared for a long siege with adequate supplies. They maintained discipline and cohesion even under devastating bombardment. And none of it mattered, because the Americans invented a weapon specifically designed to defeat those defenses, mass-produced that weapon, supplied it with abundant fuel, deployed it systematically, and used it to kill thousands of Japanese soldiers who died, unable to effectively fight back. The lesson was clear and terrible. In industrial warfare, the side with greater production capacity can afford to develop specialized solutions to any tactical problem, and those solutions will be decisive because they cannot be countered by an opponent with limited production capacity. The flamethrower tanks at Iwo Jima weren't just weapons, they were demonstrations of American industrial supremacy, physical manifestations of the gap between American and Japanese manufacturing capacity, tools that transformed tactical problems into industrial solutions. The Japanese had prepared for conventional war and encountered instead the systematic application of industrial capacity to military problems, and they had no answer because they couldn't match American production in any category. The story ends, as these stories must, with fire and silence. The volcanic rock of Iwo Jima still bears scars from the battle-collapsed bunkers, melted fortifications, cave mouths blackened by flames that burned 70 years ago. The island is uninhabited now, a memorial to the 6,800 Americans and 18,000 Japanese who died there in 36 days of combat. The M4A3R3 flamethrower tanks that burned through Japanese defensive positions were eventually scrapped or placed in museums, their terrible effectiveness rendered obsolete by changing military technology and international agreements limiting the use of incendiary weapons. But the lesson they taught remains relevant. Modern war is decided by industrial capacity, and the side with more factories, more production, more logistics, more resources will overwhelm the side with less, regardless of courage or skill or tactical preparation. The Japanese soldiers on Iwo Jima fought with extraordinary bravery against impossible odds, and they died not because they lacked warrior spirit but because they were fighting American industry, and industry doesn't care about spirit. Industry produces, delivers, deploys, and overwhelms, and in the end, the flames consumed everything: fortifications, soldiers, defensive doctrine, and the illusion that courage alone could overcome material superiority. The mathematics were written in fire, and the equation was simple: unlimited napalm plus armored delivery system plus systematic doctrine equals defeated fortifications, regardless of how well those fortifications were built or how bravely they were defended. American industrial warfare had arrived on Iwo Jima in the form of 8 tanks carrying fire, and in 36 days, those tanks helped teach the final lesson of the Pacific War: you cannot fight factories with foxholes. And abundance always overwhelms scarcity when the abundance is weaponized and deployed without constraint.